What we're talking about today is matrices. We're doing more with matrices. So, with our matrices, we're going to start off with adding or subtracting. To add or subtract two matrices with the same dimensions, add or subtract the corresponding elements. So, you don't have to write this down because I think once we start doing these, it's going to make a whole lot of sense. Because if we look at the first one here, we're going to add these two together. Well, A is in the top left. E is also in that same spot, top left. So we'll add A and E. B is in the top right. F is in the top right. So we'll add B and F. C is in the bottom left. G is in the bottom left. So we would add C and G. D is in the bottom right. H is in the bottom right, corresponding spots. So we would add those together. Subtraction, we would do almost the exact same thing, but instead of adding them, we would subtract. The sum or difference of two matrices with different dimensions is undefined. We can only add or subtract if the dimensions of the two matrices, or three, are the same. We can only add or subtract if the dimensions are the same. So if we look at this first one here, our first matrix is a 2 by 2. We have 2 rows, 2 columns. The second matrix is also a 2 by 2. 2 rows, 2 columns. Yes? So that means we can add these together. Our first number in the first matrix is 2. And we're going to add to it the corresponding number in the second one, which is 1. Yes? Because 2 and 1 are in the same spot, so we will be adding those together. Our next number that we have is -1. And we're going to add to it what? 2. Our next number is 3. And the number in the corresponding spot with 3 is 4. And our last one is 0. And we're adding to its corresponding number, which is -2. Questions on what we've done so far? We good with this here? Yes. Let's add. So our first one, 2 plus 1 is 3. -1 plus 2 is 1. Our next one, 3 plus 4 is 7. And 0 plus -2. That's it. Yes, sir. Not much. All right. This time we're not going to add. We are going to subtract. Now the first one is a 3 by 2. The second one is a 3 by 2. So we can subtract these. So our first number is 2 minus -1. Our next one would be -3 minus 2, because again, we're subtracting the corresponding elements, the numbers that are in the same spot. If we drop down to the second row, we would have 5 minus 7. Then we'd have 4 minus 8. The last row, -2 minus -5. And lastly, 8 minus 6. Any questions on how we got these numbers in each of these places? Last thing we need to do is simplify. So the first one we can do is 2 minus -1. Well, negative makes a plus. So 2 plus 1 is
3.
Our next one, -3 minus 2 would be?
5.
Yes, it would be -5. Our next one, 5 minus 7 is -2. 4 minus 8, -4.
Wait, 4 minus
Yeah. Bless you. No, you're good. 4 minus 8 would be negative 4. 2 minus negative 5. Negative and negative make a plus, yes? So negative 2 plus 5 is 3. And lastly, 8 minus 2. 2. Questions on these here? Now, if we wanted to, I could grab the graphing calculator and say second matrix, and we can go over to edit. So the last one we did, our first matrix was a 3 by 2, which was 2, negative 3, 5, 4, negative 2, 8. So I could type that in for A. We can go second quit, second matrix, over to edit, but this time we're going to put it into matrix B, because we have two different matrices we're adding, or in this case, subtracting, which is also a 3 by 2. Negative 1, 2, 7, 8, negative 5. Oh, see here, that should be 8, negative 5, 6. Yep. Second quit. Because I think we feel pretty comfortable with putting the matrices into this calculator. Yes? Okay, so we wanted to do what? Well, the first matrix, matrix A is the first one, and we're going to subtract from it the matrix we put in for matrix B, yes? Is that what we got? Mm-hmm. Although with this adding and subtracting, it's almost as fast to do it by hand as it is to type this thing into the calculator. We ready for the next one? C, so we're going to add these two together. We have addition, yes? It is indeed what? Undefined. And I will show you exactly why. Because if we went through and started adding, we would say negative 8 plus 6, yes? And our next one would be 1 plus negative 1. Then we would have 3 plus, do we have an elements corresponding to 3? No. And it's very tempting to just want to go 0, 0, yes? But is that the same matrix? No, we changed the matrix that it was. We can't do that. That is why this here is undefined. Well, here we have a 2 by 3, yes? The second one is what, A? Are those dimensions the same? We can't add or subtract. The dimensions have to be the same for us to add or subtract. If they're not, it's undefined. Does that make sense? Because they just have to match up. Now, if the second one was a 2 by 3, then we could add them or subtract them. But they have to be the same dimensions. Questions on addition or subtraction? Do we need to see another example of one of these? All right, we feel good with those. We'll move on to the next part of this here. Scalar multiplication. When working with matrices, a real number is often called a scalar. To multiply a matrix by a scalar, multiply each element in the matrix by the scalar. This process is called scalar multiplication. Okay? All right. So here, we are scaling this matrix by a factor of 2. Okay. So what we're going to do, so our first number is 3, yes? I'm going to multiply it by 2. I'm also going to multiply the negative 2 by 2. I'm also going to multiply this 1, the 5, the 2, and the 0. We're going to multiply every element of the matrix by that scalar. And that's it. Now all we need to do is actually multiply. Well, 2 times 3 is 6. 2 times negative 2 is negative 4. 2 times 1 is 2 times 5. 2 times 2, 4. 2 times 0. That's literally it. How do we feel about scalar multiplication? All right. There are more of those that we can do, but I feel like let's jump into the next part. We can do scalar multiplication and addition and subtraction. So if we do this here, we apply the scalar multiplication first, then add or subtract next. So here, the scalar multiplication of the -3. Every element in this first matrix is going to be multiplied by -3. We'd have -3 times 5, -3 times 0, -3 times -2, and -3 times 4. -1, 7, 3, 2. Now, since there's not a scalar or a number in front of the other matrices, it's not being scaled. So we can multiply by our -3. So -3 times 5 is -15. -3 times 0 as well, 0. -3 times -2 is +6. And -3 times 4 is -12. Since they are both 2 by 2s, we can definitely add these two together. So our corresponding elements would be -15 plus -1. Then we'd have 0 plus 7. Next row we'd have 6 plus 3. And lastly, we had -12 plus 2. -15 minus 1 is -16. 0 plus 7 is 7. 6 plus 3 is, and -12 plus 2 is. That's it. Now I will say, once we start applying multiple scalars and multiple addition subtraction, then the calculator is starting to get a little bit quicker. But on a whole, neither one of these is overly time consuming as what some of the stuff we've covered in this chapter. So let's look at that here. Let's do this one. So the first thing I would need to do for this is to input the first matrix. Now for us here, it is a 2 by 2. So we have 5, 0, -2, 4. Second quit. Second matrix, we'll go over to B for our second matrix. -1, 7, 3, 2. I can quit. Because I think we feel comfortable getting those in, yes? And if I wanted to add a third matrix to this, we can just name it in C, the third one. Okay. Now, if we look back at this problem, back up at the top, I have defined this matrix as A and this one as B. So our statement's looking like -3A plus B, yes? So in the calculator, I'm going to start off with -3, second matrix A, plus second matrix, go down to B, and we have it here. So essentially we type it in exactly as it seems for A, B, C. And that's it. Questions on this here? Do we feel comfortable with this here? Do we need to see another example of one of these? If not, yeah, the rest of the class time to work on this here.